So today's lesson is called Representing Quadratic Relations. And what we're literally trying to do today is to maximize our knowledge and understand the math behind the geometry. Let's call it the shape. All right. So pause the video, make sure you have this written down as your title, and then go and do the enriched lesson that I've provided for you. This lesson should take about 25 minutes. So imagine we have the quadratic relation y is equal to x squared plus 2x minus 15. We need to figure out whether this equation has a maximum or a minimum, okay? We also need to find out what is the y-intercept, right? And what are the zeros of the solution. Now, today's lesson is all about explaining how all of this stuff comes together, okay? Now, the first thing that we're going to do is we're going to identify if our equation has a maximum or a minimum. Now, let's go and take a look at the basic equation for our parabolas. Now, as an aside, you're going to have your note, and then there'll be a calculation beside it. That's what we'll do for this lesson. And then we'll summarize it at the end. So the basic equation for a parabola, also known as a quadratic, is given by this standard basic equation. Y is equal to ax squared plus bx plus c. The type of calculations that we have allow us to look at these equations and say whether our equations are opening up or down without having to graph them. So for example, if I have the following for my equation, for my parabola or quadratic, you'll write y is equal to, let's say I have y is equal to x squared plus 2x minus 15. I can tell you that based on this original equation that I have above here, the a value doesn't have anything there, but really it's a 1 that's sitting in front of the x squared term. Now, this a value that we're looking at is greater than 0. So this means our graph opens up. So our graph looks like this. Okay? Or it looks like this. Or it looks like this, just touching the x-axis. But I'm going to tell you right now, it actually looks like this when we graph it. Now, based on all this information, we can determine that this is a minimum. So now let's go and answer that first question. So you go A, since the A value is bigger than 0, that means that the graph opens up which means it is a minimum. Now, let's go back to our quick note here, right? So now imagine if I had another equation like this. Y is equal to negative x squared minus 2x plus 15. So all we've done is taken the negative of all this, right? The key concept is if a is less than 0, this thing opens, well, this one opens down. So instead of opening up, it opens down. And in this case, our A value is, instead of 1, it's -1. Okay? So it opens down. So our graph would look like this, either underneath the graph, or looks like this, crossing the graph, crossing the x-axis, or looking like this, just touching the x-axis at the vertex, right? And because this is the case, we can kind of give an idea of what actually is happening. So when it opens down, this is a max. When it opens up, it is a minimum. So let's put this in blue here. So we have a max here. No, a minimum there, because it's opening up, and it is a max if this thing opens down.